Hello, today we're going to talk about visualizing regressions using Anscombe's Quartet. And I'm going to break this into three different presentations. The first is going to be on the visual intuition of graphics. The second one is going to be on regression tables. And the third one is going to be called Caveat Emptor. Let the buyer beware, what are the limitations, and some of the common mistakes when interpreting regressions and visualizing regressions. So let's go ahead and start looking at the screen. So here we've got visualizing regressions, and this is part one, the visual intuition behind regressions. So I'm going to be looking at a regression function, and a regression function at its most basic level is trying to take a set of scatter points in a scatter plot and fit a line through those points as best as possible. You'll note that the line goes approximately midway through any vertical cross-section of this data. So if I was to draw a rectangle through any portion of this data, you'll see that the regression line hits midway between the data points in any cross-section of this data. Not in all of them, you can't do it perfectly, but the math is going to try and make it as perfect as possible. The line is represented by an equation that you guys are all very familiar with, y is equal to beta x plus c. You'll have seen that in different contexts. You'll have seen it in the context of y is equal to mx plus b or y is equal to ax plus b. These are all ways of indicating a straight line. Beta in this case is the slope of the line, so 1 unit change in x1 is associated with a beta unit change in y1. 1 unit change horizontally corresponds to a beta unit change vertically. C is the constant, it's the y-intercept value, it's the value of y when x1 is 0. So we use linear regressions because they often sometimes fit our data properly. And we're going to be talking about a lot of ways in which the data does not fit properly. And one of your homework questions is, which of these graphics has a proper fit for the linear regression line? The answer is that there's only one of them. The reason that we're looking at data is because it can highlight when the assumptions behind our statistical models don't hold, and where therefore the estimates that we get out of our regression models, out of our statistics, are potentially incorrect. So here we're looking at various problematic data points. This last one is a graphic that the bottom right is a graphic that is really just improperly modeled by any kind of line at all, whether it's curved or straight. You've got a whole clump of data points at 8, and they've got one outlier all the way over at x4 is equal to 18 or 19. This is a horrible use of a linear regression. Don't apply linear regressions to data that looks like this. You do want to apply linear regressions to data that looks like the top left. This bottom left also has an outlier. It's this point at y3 is equal to 13, and that is a point that would violate the assumptions behind a regression. You can have outliers that aren't quite as obvious as in the Anscombe's Quartet data. So here point A is an outlier, and the reading on July 2nd is going to demonstrate some of the reasons why that would be an outlier. Scatter plots effectively reveal these distorting points. So that's the section on visual intuition of regressions and scatter plots. Next video will be on regression tables.